Hello and welcome. In this video, we're going to look at a series parallel circuit in TinkerCAD. So in this case here, we were given a voltage supply location. A to D is going to be where we put in our battery terminal. And so that's going to give us perspective for the circuit. So that means that our voltage line across the top needs to connect to the very beginning of our R1 resistor, right? That's right where node A connects to. So we can do that now. We can say that if we did that from the positive terminal down to node A here, that is going to be our A location. We can connect that directly through our R1 resistor, and that's going to be on this other side, which means that this other side of R1 over here leads us to point B. So we can say that point B is actually found right here at the end of R1. We can call that point B. We'll circle that. We see that point B actually connects to a couple of spots, so it's actually a little bit larger than we expect there. We know that there are a couple of different pathways we can take from there. We can go up through R2 and R3 across, and that leads us down to point C. We can circle point C in a different color here so we can spot it. So we know we need to go through R1 and R2. So we can take R1 here, we can go straight through R2, and from R2 on the other side there, it shows that we're going through R3 as well. So we'll go from R2 all the way over to R3, which means at the end of R3 right here, that is going to be our point C location. We also see a secondary path here. We can go through the bottom side of B through R4, and that also leads us to point C here. So we can take that path. We can say that the point B location can go all the way over to the start of R4, and that means that this bottom of R4 is also node C. Right? This bottom here should be node C. So we need to combine these two nodes. So when we look back at our circuit, we see that the next combination follows down, around, and in through R5 down here. So that's a series connection. We have no choice but to go through that. And so we need to connect our R5 resistor here as our next location. It needs to be node C. So we'll take our current node C up here at the back of R3 and connect it to the R5 location. And then we'll take our node C from the R4 and connect it to an R5 location, which means that now this is also node C. From here, we see that the R5 leads us directly to node D, and that is going to be our ground location. And so in this case, we can just go from R5 directly to ground. Now we've got that whole branch set up. We've got one more possible solution here. We can go from node B across R6 to our D location also, which means that this bottom whole thing down here is going to be our D location. And we can connect that from our B. We want to go down to our R6, across our R6, and down to our D location. And that is our total circuit. So let's clear these out, and we'll look at this from the simulation side. Here's our schematic view. We can zoom in on this. We can compare these two schematics here, because we have a battery terminal right here that leads us up, and that's our positive line. We go through R1. That's the same as the other one here. We go through R1. That leads us to node B here. After that, we travel down and hit this node, and that is actually this dual node here, and it goes straight through R6 to our ground location. So we see that right here, R6 to our ground location. From there, we can continue on and hit another node, and that is going to be this node right here that is between R2, 3, and R4. Specifically, we're hitting the R4 first and leading to point C down here. And so that's what we see over here, where we go straight through and hit point C. And we also know that there's another pathway that leads through R2 and R3 in series, and that comes us down to node C as well. And so that is our upper pathway for that, leading down to node C. After that, from node C, we go through R5 and go back down to our ground location. And we see that over here where C loops around, goes through R5, and meets up at that D location at the bottom, and that is our ground location. Right. So to write out the equation for this, we would need to know which ones are in series and which ones are in parallel. So from the positive lead here, we can travel up and say that that's R1 with no choice but to go through it. So we can say that RT is equal to R1 in series. The series is going to be represented by this plus sign. We have no choice but to go through it, therefore it is plus the next component. As we follow through here, we see that this parallel node hits. Anytime you hit a parallel node, you can open a parenthesis. We see that goes through R6 to ground, so we'll say R6 is in parallel with whatever else is in the circuit here. We continue on and we hit another node, so we'll open another parenthesis. We say that goes through R4 to node C. So we'll say R4 is in parallel with something else. We know that something else is R2 and R3 in series with each other before they enter back into node C also. So we'll wrap those up in their own little parenthesis here so that we know that we need to add them, R2 plus R3, before we put them into that parallel with R4. Right? And since we closed off that C node right here, we can close this off up here with our parenthesis. We can keep going through R5 down to our ground location where R6 stopped at. So we'll say that that is no choice but to go through R5 from that spot. So we'll say plus R5, and we'll close off our parenthesis. So from here, you want to work innermost parenthesis first. So you'll do R2 and R3 added together. Those are your series components. You'll place that value in parallel with R4, and then you'll add that to R5, and you'll take that whole value there and put it in parallel with R6, and then add R1 to the final answer. And that will be your total resistance. Okay, let us know if you have any questions.